This is the second part of question 11 in the 4.1 4.2 notes. So in question 11, we were originally given the graph of f prime, and we had to read information off that graph to create the f prime sign chart and the f double prime sign chart. So now we're going to use those sign charts to create a possible sketch of the original f of x function. It's a possible sketch. So how are we going to do that? Well, I know I'm going to need to read the first derivative graph to get information about the local extrema of the f of x graph. And I'm going to need to read the f double prime sign chart to get information about the shape or the concavity of the f of x graph. Okay, so let's look at this f prime of x sign chart and get information about the local extrema. Well, I can see my tangent lines were going up, went horizontal when it hit 0, and went back down. So there's going to be a local max when x is equal to -3. And then my tangent lines were going down, hit 0, so went horizontal, and then bounced back up. So there's going to be a local min where x is a +1. So I'm going to locate those on my graph. Now, the first point you plot, you have lots of freedom. Okay, so let's plot this local max first. I'm going to come over here to -3. I can plot that local max anywhere on this green line. I can plot that local max as high or as low as I want it, as long as it lines up with the input -3. Okay, so I don't know. It's a local max. Let's kind of make it extreme. Let's put it way up here. Okay, now once I select that point, there's going to be some restrictions on everything else I plot, but I have a lot of freedom on that first point. I can put it as high as I want as long as it lines up with the input -3. So it did. Okay, and I'm going to mark this with a horizontal tangent line, just make it super obvious. It's a horizontal tangent line there. I'm going to label it a local max. So local max. Okay, and now I can plot that local min when x was equal to +1. Okay, and again, that local min now it needs to line up with this input where x is 1, but it needs to be below that local max. So as long as I plot it below the local max, but align it with that input x equals 1, I'll be okay. And I'm going to, again, make it pretty exaggerated. So let's put it way down here. So I'm going to mark this horizontal tangent line, went horizontal there for a split second, and I'm going to label that my local min. Okay, so I've labeled those. I'm going to erase these guidelines. Now I need to plot my inflection point. So my inflection point is where my concavity changes. And I can see my concavity changes from concave down to concave up when x is a -1. So I can put that inflection point anywhere on this green line between my local max and my local min. So you have some freedom where to place it, but it has to line up with the input -1, and it has to be between those local extrema. So let's put it right here. Okay, and I'm going to label that as my inflection point. That's where my concavity is changing. So I'm going to label this inflection point. Oops, inflection point. Okay, and now I need to connect these points on my graph using the concavity. I'm going to use my information from the second derivative sign chart to connect these points. So from -infinity until I hit my inflection point, so this is my inflection point, until I hit that inflection point, this entire region over here needs to be concave down. So I'm going to sketch a graph concave down there. So let's hit that local max, concave down. All of this is concave down. So I'm going to label that. So everything in that region, concave down. And then after that inflection point, I'm going to go concave up. So after -1, my concavity changes. So everything in this region that I graph needs to be concave up. So I'm going to go ahead and do that. I'm going to do concave up. Going to hit my local min and just bounce back up. And all of this region was concave up. So I'm going to label it. Okay, and I've created a possible function for f of x here. Again, that local max could be as high as I want it. It just has to align with the input x equals -3. That local min could be as low as I want it. It just needs to line up with x equals 1. It's kind of off there, my local min. I don't know. Let me write in here that I'm just going to emphasize, I'll write in red that it was supposed to line up at 1 because it's kind of like cattywampus right now. Here, you know what? I'll just move my input. There we go. Not drawn to scale, right? And over here, let me just emphasize that this local max happened at -3. You know, that's where it's hitting 0. Okay. And I can see that I've created an odd function, which makes sense because the derivative that was graphed was quadratic. So it was an even function. So I'm expecting the original function was odd because it'd be 1 degree higher than my derivative. So I'm pretty sure I got it correct here. The important things to remember is just, you know, label everything if you're unsure. Just label everything to make it easier for the grader to read. And also remember, if this was on MyMathLab or you're looking at the answer key in the notes, this graph will look different than the possible graph in the notes answer key or in MyMathLab. This graph could be shifted, either shifted up or shifted down. As long as those local mins and local maxes are lining up with the input, this graph could be shifted vertically anywhere. Okay, so your graph that you create might look different than a classmate's, like might look different than an answer key, but it could still be correct as long as those mins and maxes are aligning with the right input and that inflection point is aligning with the right input. Okay, and with that said, if you sketch something and you're not sure if it's right, just shoot me a picture and I can give you either a thumbs up or point out things that need to be corrected.